All right, this is section 5.3, part 2. We're talking about multiplicities. Okay, notice how at x equals -3, it's a straight line here. We said that's odd. At x equals -1, it goes through like it does at x equals -3. That's odd. X equals -2, it bounces off, so that's even. Okay, so we have odd multiplicities for -3 and -1, and an even multiplicity for 2. Okay, so let's look at this right here. This one right here has a single 0. Okay, so just going straight through right here. Um, Here we have a 0 with multiplicity 2. Right here, notice it's even, it bounces off. And we have 0 with multiplicity 3. Now notice how the multiplicity of 1, that is a straight line. The multiplicity of 2, that almost looks like a parabola. Remember, x squared looks like a parabola. Y equals x, that is just a straight line. And here, multiplicity 3, that looks like y equals x cubed. Okay, because x cubed looks something like this right here. Okay. Graphical behavior of polynomials at x-intercepts. If a polynomial contains a factor of the form x minus h raised to p, the behavior near the x-intercept h is determined by the power p. We say that x equals h is a 0 of multiplicity p. Basically what we are saying over here, get rid of some of these. Notice how we have x equals -3, but x plus 3 over here, x equals -1, but x plus 1 over here, x equals 2, but x minus 2 over here. Okay, so they're opposite from each other. So that is the factor form, the x plus 3, x minus 2, x plus 1. That's the factor form. But the actual zeros are the opposite. Basically, you take the inside, like what we did here, and we solve for 0. Okay? Or sorry, we set it equal to 0 and we solve for x. That's how we get the zeros of that function. Now what they are raised to, 1, 2, and 3, those are the multiplicities. So here our p-value right here, that is a multiplicity. Okay, so we say that x equals h is a 0 of multiplicity p. The graph of a polynomial function will touch the x-axis at zeros with even multiplicities. The graph will cross the x-axis with zeros of odd multiplicities. The sum of the multiplicities is the degree of the polynomial function. Okay, so if the graph crosses the x and appears to be almost linear, it's a single 0 or a multiplicity of 1. If the graph touches the x-axis and bounces off, it's a 0 with an even multiplicity. If it crosses the x-axis at 0, it is an odd multiplicity. And the sum of multiplicities is n. Basically what I just said right here. The sum of the multiplicities is the degree of the polynomial function. Okay, so let's interpret the turning points like we talked about in section 5.2. A turning point is a point in the graph where the graph changes from increasing to decreasing or from decreasing to increasing. A polynomial of degree n will have at most n minus 1 turning points. Okay, so if we go back to this one, and let me clean it up just a little bit. So if you look at this right here, here's our function. Let me clean this up as well. Okay, so there's our function. If we wanted to find the degree, we need to put it in the general form, which means, I have a 2 right there and a 3 right here, which means I would need to multiply this out. But really what I'm going to do is, since it's the highest number, x is raised to the highest number, This would be just an x because it's raised to 1. This would be an x squared. This would be x cubed when you multiply it all out. So here what I have is x raised to, that's 1 plus 2, 3, plus another 3, 6. Okay, now let's count the turning points. We have 1, 2, 3, 4, 5 turning points. I add one more to that to give me the degree, which would be 6. Same thing here. Okay, so we have a degree of 6. So our multiplicities should add up to 6, which it does, and we use those to get that. Okay, so the turning points and the degree will go hand in hand here, and that will help us figure out some of these examples. Use the graph of the function in the graph below to identify the zeros of the function and their multiplicity. Okay, so looks like I have x-intercepts or zeros at x equals -3 right here and x equals 4 right here. Okay, so there's my zeros. Now I need to figure out their multiplicities. Well, since this one just touches the x-axis, I know that this is going to be an even multiplicity. Since this one goes through the x-axis, I know that this is going to be an odd multiplicity. And also I have one right here. I almost missed that one. -1. It goes straight through, so this one is odd as well. Okay? So I have x equals -3, x equals -1, and x equals 4 for my zeros. Let's figure out their multiplicities. So let's move all of this. Okay, we said that this first one was going to be, we'll write above it, this one's supposed to be even, this one should be odd, this one should be odd multiplicity. Okay, so let's count the turning points. We've got 1, 2, 3, 4, 5 turning points. So that means my degree should be equal to, how many did I say? 1, 2, 3, 4, 5, so 6. So I need the multiplicities to add to 6. So I know that this is going to be even. Let's look at this right here. It looks pretty straight. Let's say that it's 1. This looks like the x cubed. So let's say that's 3. And so I have 4, and this one's even. That should be 2. Okay, so we have x equals -3, multiplicity, we'll just say multiplicity of 2. This one would be a multiplicity of 1, and multiplicity of 3. When I add that together, that does come out to 6. So there's your answer there. All right, same thing. Let's figure out the x-intercept. So we've got x equals -3, x equals 2, and x equals 5. Okay, I'm going to count the turning points. So I've got 1, 2, 3 turning points. So my degree has got to be 4. 1, 2, 3. Yep. Okay, so my zeros are at x equals -3, x equals 2, x equals 5. This one cuts through, so this one should be odd. This one touches, bounces off. This one should be even. And this one cuts through, so this one should be odd. Okay, so multiplicity of, go ahead and write that for all of them. Okay, so these have got to equal up to 4. Notice how this is a pretty straight line here and here. That looks like a multiplicity of 1. This should be even, so that should be 2, and that will add up to 4. So multiplicity of 1 for this one, multiplicity of 2 for this one, multiplicity of 1 for this one. Okay, so, and that would equal 4, which is the same as our degree. Okay, so let's find the intercepts, and looks like I have one at x equals -3, x equals -2, x equals 3, and x equals 4. Okay, and all of these, they go straight through, so all of these are going to have odd multiplicities. So x equals -3, x equals -2, x equals 3, and x equals 4. And we've got 1, 2, 3 turning points. So the degree is going to be 4. Okay, so multiplicity of. Okay, notice how all of these, when you get close to it, these look like a straight line, pretty straight line going through these. Okay, so all of these would be 1. So all these have a multiplicity of 1. All of those are odd, and when I add all those up, they come out to be 4, which is the degree of this polynomial. Now for this one, which we've already looked at, we've already figured out the zeros and multiplicities for this one. We need to write a formula for this polynomial. Now back here, we figured out that we had zeros at -3, 2, and 5, and a multiplicity of 1, 2, and 1 for those, respectively. Okay, so we're going to put this in factor form. So f of x is equal to x, we had a -3, so I'm going to change that to plus 3 raised to 1. X, we had a 2, so I'm going to change that to a -2. Multiplicity of 2, raise that to 2. And then x, 5, so I'm going to change that to -5. Multiplicity of 1. So really we could just write x plus 3, x minus 2 squared, x minus 5. Now I can't leave it like that because this could be stretched or it could be compressed by a certain number. So I need to put an a right in front of these. And to figure out this a, I'm going to use a nice point on this graph. Say we pick this point right here. So that's a y-intercept. So this is going to be 0, comma, -2. And I'm going to plug that into my function here. So f of 0 is equal to a. So it'll be 0 plus 3, 0 minus 2 squared, 0 minus 5. And this right here, f of 0, really that's just y at 0. So that's -2. So let me change that to -2. So -2 is equal to a. This is 3, -2 squared, -5. So this is 3. -2 times -2 is 4 times -5. Okay, so we have 3 times 4 times a -5. That will give us -60. We're going to divide both sides by this -60. Okay, I'm going to come over here. Okay, so a is going to be positive, and then take a 2 from both of them, so 1 over 30. Okay, so to complete our formula, change that to 1 over 30, and then that is our final answer for this function right here. Now let's look at this one, and we've already looked at the multiplicities and the zeros. So we could write f of x. I'll go ahead and write that a there. We had x plus 3, x plus 2, x minus 3, and x minus 4. All these had a multiplicity of 1. I'm getting these from right here. There's a -3, change it to +3. There's a -2, change it to +2. Here's a 3, change it to -3. Here's a 4, change it to -4 like I did here. Now we're going to pick a nice spot on the graph and plug it in and try to figure out what a is here. I'm going to use this point right here. And notice this is -1, -2, there's -3, -4, and -5. So this is 0, -3. So this is going to be -3. A, 0 plus 3, 0 plus 2, 0 minus 3, and 0 minus 4. So this is going to be 3, 2, -3, -4. This will be times 72. Divide both sides by 72. So -1 over 24 equals a. So -1 over 24, and there's our answer.